Good afternoon, everyone. My name is Tian Lan. We spend about one-third of our life either sleeping or attempting to do so. Sleep is the most familiar thing to us. But have you ever been thinking about the sleep of animals? I ask this because today I'm going to present an article based on research of animals' sleep process. To start with, I will explain why we should do research on animals' sleep. After that, I'll introduce an experiment about dogs' sleep and then discuss the result of it. It will take about 5 minutes to cover this. I plan to keep some time for any questions after the presentation and will email the PowerPoint to anyone who would like it. Well, I'd like to show you a picture first. As you can see, there's a lovely sleeping dog on this picture. Usually, the sleep research focuses on humans only. However, research on the sleep of animals is also very important to understand this our most familiar process. Because both humans and animals have similar sleep cycles, this may indicate similarities in sleep quality and experience. Sleep has positive effects on humans' memory. Scientists call this process memory consolidation. During the memory consolidation, your brain pulls together pieces of information and packages them into memories that can be used in the future. Moreover, memory is also important for dogs. Working dogs need to learn and retain different job-specific skills, and companion dogs often learn basic skills to successfully live alongside humans. So, the question is, when a dog learns some new things, can sleep help the dog perform those skills better? Researchers in Hungary have devised a way to non-invasively peer into sleeping dogs' brain to explore the content and function of their sleep. In the experiment, they gave dogs a learning task and then peered into their sleep with non-invasive electroencephalogram, which is a test that detects brain electrical activity using small electrodes attached to the scope. 15 companion dogs participated in this behavioral experiment and have been divided in two groups. The first group with a learning condition and the other with a non-learning condition. The learning condition means that experimenters taught the dogs the command for sit and lie down in a foreign language, in this case English. In the non-learning condition, dogs simply practice the sit and lie down commands that they already knew in Hungarian. Nothing new. After learning, dogs went to sleep. Dog snoozing-related brain activity was then monitored over the next 3 hours. Afterwards, dogs in the learning condition were retested on sit and lie down in English to determine whether sleep helped the dogs to process what they have learned. The results surprised the scientists. Not only the sleep affected dogs' learning, but also the learning affected dogs' sleep. Dogs responded better to sit and lie down in English after taking a snooze. But before the dogs in the learning condition were tested, two notable wave patterns were detected in the electroencephalogram spectrum in the non-rapid eye movement phase, the dreamless part of sleep. There was an increase of delta power similar to what has been found in humans and a decrease in alpha activity, which pointed out that sleep depth was increased after learning. Actually, these two findings are related to each other. Dogs learned a task which affected their brain activity during sleep, then they performed better on the task. At the end, my take-home message is that the newly acquired information is processed and consolidated during sleep. Taking a snooze can improve subsequent performance for both humans and animals. That, ladies and gentlemen, was what I want to share with you today. Thank you very much.